I thank the organizers for the invitation. It's greatly appreciated. The title of my presentation is From the Ground Up, Soil Health for Climate Change, Mitigation, Resilience, and Food System Transformation. Pre-agriculture, the carbon stock in the atmosphere was 360 gigaton. In 1750 circa, pre-industrial revolution, it increased to 560 gigaton. The 200 gigaton increase primarily came from land use conversion for agriculture. Present, the organic carbon total stock is 880 gigaton in the atmosphere, which is since the industrial revolution increase of 320 gigaton, contributed both by fossil fuel combustion and agriculture. Therefore, agriculture has been a major source through land use conversion and land use soil management of carbon emission into the atmosphere. That's indicated by the short-term carbon cycle. The total carbon stock of 880 gigaton at present is increasing at the rate of 5.4 gigaton per year, primarily through fossil fuel combustion of 10 gigaton and about 1.5 to 1.8 gigaton through deforestation and land use conversion. At the same time, photosynthesis takes from atmosphere about 120 to 123 gigaton of carbon every year, of which 60 is returned back immediately through plant respiration, and another 60 transferred to the soil and returned to the atmosphere through soil respiration. In addition, accelerated soil erosion as per the hydric erosion contributes 1.1 gigaton per year of carbon, but it is not accounted for in the global carbon budget. However, 0.6 gigaton of carbon is transported by sediments into the ocean and buried there, probably sequestered, so to say. Yet, the ocean absorbs about 2.6 additional gigaton of carbon from the atmosphere, which is also increasing acidification and along with global warming may over time decrease uptake by the ocean. Soil organic matter content indeed is a source of many ecosystem services, including water resources quality and quantity, climate change mitigation adaptation, food security, both quantity and quality, and biodiversity, both above and below ground. Yes, indeed, soil organic matter is the heart of soil health. And soil health is soil's capacity as a dynamic and biologically active entity within natural and managed landscapes to sustain multiple ecosystem services such as net primary productivity, food and nutrition security, biodiversity, water purification and renewability, carbon sequestration, air quality, and atmospheric chemistry, along with elemental cycling for both human well-being and nature conservancy. Threshold level of soil organic matter content for optimum soil health is about 3 to 4%. If the organic matter content is decreased drastically, soil productivity and ecosystem services are also jeopardized. For example, in sub-Saharan Africa and soils of South Asia, elsewhere in Caribbean regions and Andean region of Central America, along with other countries, soil organic matter content of depleted soil is less than 0.5%. In some cases, as low as 0.25 to 0.1%, which has a very serious impact on the use efficiency of input and sustainability of the productivity. If we can create land use which creates a positive ecosystem and soil carbon budget, the possibility of carbon sequestration from the atmosphere into the terrestrial biosphere in wetland restoration at the rate of about 1.5 tons per hectare per year, afforestation or conservation reserve program about 1 ton, no-till about 0.3 to 0.5 ton, rangeland about 0.1 to 0.2 ton, and recreation land and urban ecosystem, homeland, etc., about 0.75 to 1 ton of carbon per hectare per year. Increasing organic carbon content by 1 metric ton per hectare in the root zone top 30 centimeter, for example, can increase productivity of crops such as corn by 100 to 300 kilogram per hectare, soybean 20 to 50, wheat 20 to 70, rice 10 to 50, sorghum 80 to 140, millet 30 to 70, beans 30 to 60. Overall, about 40 to 100 kilogram per hectare additional grain for every incremental increase of 1 metric ton of carbon per hectare per year. Therefore, sequestering as much as 10 metric ton per hectare in cropland of depleted and degraded agroecosystem can drastically increase productivity and the nutritional quality of the food produced. Therefore, it is important to emphasize the fertilizer management through CNPK. C means carbon coming before the NPK rather than the NPK alone. If the organic carbon content is increased, the need for NPK will decrease. Consequently, the technical potential of carbon sequestration in soils of the world, all soils, is about 2.5 gigaton of carbon per year. And combined with the management of improved systems, the soils of the world between 2020 and 2100 can sequester as much as 178 gigaton, vegetation, tree biomass above and below ground, another 155, together 333 gigaton, which translates to about 157 parts per million of drawdown of CO2. Therefore, if we can find no carbon or low carbon fuel sources, which take effect immediately, definitely by 2030, and we adopt nature positive agroecosystem, it is possible to limit global warming to 2 degrees centigrade. In this regard, farming carbon is very important, which means farmers should be rewarded for carbon sequestration and create an other income stream. So they have an income source at a societal value of about $130 per ton, which means $35 per ton of carbon credit or 1 ton of CO2. If a farmer sequesters half a ton of carbon per hectare, they should get about $65 per hectare. If they sequester 1/3 of a ton, about $40 to $43 per hectare. Technological innovations, which can create a very bright future for agriculture ahead, include recarbonization of soil and biosphere, pro-nature agriculture, saving land for nature, climate resilient agriculture, eco-intensification, rhizosphere processes, phytobiome robotic and soil-less agriculture, urban agriculture, sky farming, space farming, and soil processes under hypergravity conditions. Precision agriculture, the nexus approach, nutrition-sensitive farming, farming soil rather than farming crops, with plants that emit molecular-based signals or sentinel plants for remote sensing and targeted interventions, including farming carbon. The One Health concept is very critical, which means the health of soil, plants, animal, people, ecosystem, and the planetary processes is one and indivisible. In this regard, soil health is very important. The Coalition for Action on Soil Health, which was developed at Action Track 3 program of the UN Food Systems Summit, calls specifically for the establishment of multi-stakeholder coalition to facilitate the adoption and scaling of soil health restoration practices with outcome for growth, productivity, rural livelihood, climate, and nature. In this regard, I'm very pleased to say that PSGG Coalition for Soil Health supports Soil Hub by recognizing the need for private sector participation and engagement, acknowledging tangible ecosystem-related goals and solutions, highlighting the work that is being accomplished through existing initiative and alliances, and finally emphasizing the need for science-based approaches and measurements. The mantra for Soil Health Coalition and its adoption is very simple, but very meaningful. Healthy soil equal to healthy diet, equal to healthy people, equal to healthy ecosystem, and equal to healthy planetary processes. Thank you.
you.